Hello students, welcome to Saurav Sir's classes. In our today's video, we are going to solve the first question of IIT JAM 2019 question. So we are going to solve this paper of IIT JAM 2019, and in our this video we are going to solve question number 1. So let's start question number 1. So question number 1 follows something like this. The question goes like this, that the equation of the tangent plane to the surface this x square z plus 8 minus x square minus y to the power 4 equal to 6 at the point 2, 0, 1. So the question needs to be this. So the question is asking that we need to find the equation of the tangent which is at the surface of this curve at the point this. So the value this, we need to find the value of tangent or the equation of tangent at this particular coordinate axis. So we will continue solving this question in our this video. So let us discuss the options first. See, as it is a question regarding the equation of tangent, and we know tangent is anything which just passes through one point of a curve. So this tangent is always a straight line, and we know that this equation of straight line is linear. So you can see that in these options, option A, B, C, D, all the equations which are given are linear in themselves, and all the equations depends only on two variables, that is x and z. So the equation, the y part which is given here, must vanish during the course of the solution of this video. Okay students, now moving forward towards the solution of this question. So now we are moving forward to the solution of this question. So solution of this question. Okay, so the equation of a surface is given. The equation of surface is given x square z plus root under of 8 minus x square minus y to the power 4, and this is equal to 6. So this equation we are provided with. So let this equation be equation number 1. Okay, now we need to find, we know that the general form of equation is general form of equation of tangent can be written as, so since we are asked to find the equation of tangent, so let us first write that what is the general form of equation of tangent. So we are writing the general form of equation of tangent, and it can be written when we need to find it in three axes, that is x, y and z. So the equation goes something like this, that z minus z naught equal to z of x multiplied by x minus x naught plus z of y multiplied by y minus y naught. So this is the general form of any equation of tangent. So let me highlight this part because we are requiring this in later part of this video, and we are writing this equation as equation number 2. So let us first discuss that what is this zx and what is this zy. So this zx and zy are nothing but the derivative with respect to x and y respectively. So now I have told you that this zx and this zy are the derivative of this function, this surface equation with respect to x and y. So this is very much clear from this statement that we need to find the derivative of this equation with respect to, so we need to find the derivative of this equation with respect to x and y. Okay, so now we will continue this problem and we will find the derivative of this surface. Now let us find the derivative of equation 1. So our equation 1 was this, so we are required to find the derivative of this equation with respect to, first we are finding it with respect to x and then we will find it with respect to y. So let us differentiate this equation with respect to x. Okay students, so now we are going to differentiate this with respect to x. See, this function contains x, z and y, all the variables are there, but we need to only differentiate it with respect to x. So our differentiation, our derivative will be something like this: x square dy dx of z plus z dy dx of x square. We have followed the UV rule. The UV rule we have followed. I hope you all know what is UV rule. Plus this portion. So root over derivative, it would be 1 by root under 8 minus x square minus y to the power 4, and there will be a 2 over here into d by dx of, now we are following the chain rule. So first we have differentiated this entire thing. Now we are differentiating the portion which is there inside the square root of this part. So now we are differentiating 8 minus x square minus y to the power 4, and if we differentiate the right hand side with respect to x, and on the right hand side we only have a constant term, so it will be 0. So our right hand side will become 0 and our left hand side will be something like this. Our left hand side will be x square zx. Now zx is nothing but the derivative of z with respect to x, plus, since in this part z is constant and we are differentiating this x square part, so it will be 2x z. Now see, this part will remain the same and we will differentiate this part. So 8 is a constant, so its derivative will be 0. Minus x square can be differentiated with respect to x, so it will become minus 2x, and minus y to the power 4, since we are differentiating it with respect to x, so it will also be 0. So our form will become something like this. Okay, and on the right hand side we have a derivative of 6 and it will become 0. So we have we have reached to this part of the solution. Now you can see that this 2 and 2 will cancel out, and the last form which we will get is 2xz plus x square zx minus x by root under 8 minus x square minus y to the power 4 equal to 0. Now the important thing here to notice or to take into consideration that we are asked to find the tangent at the point 2, 0, 1. So this is our x value, this is our y value, and this is our z value, and we are asked to find the tangent at this point on the surface. So these are our coordinate axes given. Now we will put these values in this equation and we will achieve to a final equation. So let us put this value on this equation and see what we are getting. So we are putting this value of 2 in all the x which we have with us. So we will put the value of x, we will put the value of z, and you can see that the value of y is 0. So anywhere where we are seeing y, we will simply put 0. Okay students, okay, moving on. So it's 2 into 2 into 1, since the value of z is given to be 1, this is 1, plus 2 square into zx minus 2 upon root under 8 minus 4 this is 8 minus 4 y 4, 2 square is 4, and minus 0, it should be equal to 0. So on solving we are getting 2 into 2 is 4 plus 4 of zx minus 1. Why 1? Because 2, we are doing a rough over here. 2 by root under 8 minus 4 is nothing but 4, and root under 4 is 2, so 2 by 2 cancel and it is 1. So we are writing the value 1. So this is our first equation, and from this we can find the value of zx. Now moving to the previous part, we need a value of zx. We have already discussed that we need the value of zx in order to solve this question where we are asked to find the tangent at the plane of this. So we need to find the value of zx. So you can see that we are slowly and steadily moving to the part zx. So this is the stepping stone of solving this problem. So 4zx equal to minus 3, and the value of zx we will get is equal to minus 3 by 4. So this is our value, and we need to keep this value with us because we need this value in the later part of the video. So we are just highlighting this value with red ink because we are needing this value in the later part of the video. So we have solved the value, the derivative with respect to x. Now we need to find the derivative of this equation with respect to y as well, because in the general form of tangent we both have zx and zy. So we will need to solve the value of zy now. So moving on and solving the value of zy. So now we are going to solve or find the derivative of the equation 1 with respect to y. So what was the derivative, what was the equation 1? So let us go in the previous page and find that what was the equation of the surface. So the surface equation was this. So we will write the surface equation. The surface equation was x square z plus root under 8 minus x square minus y to the power 4 equal to 6. So this was our equation 1, and we are going to differentiate or define the derivative with respect to x on both sides. Okay, so we have to find the derivative with respect to x. Sorry, we need to find the derivative with respect to y. So it will be y, not x. So it would be y, because we have already found the value of derivative with respect to x. Now it's time to find the value of derivative with respect to y. So now we are going to differentiate this equation with respect to y, and it will be very simple because you can see that we have y only in this part of the equation, and this part is completely rid of y. So we will get on differentiating with respect to y, we will get x square into dy dy of z plus 1 by 2 into root 8 minus x square minus y to the power 4 into dy dy of the interior part of the root value. Again we have followed the chain rule. We have differentiated this value and we've got this value, and now we will differentiate the value which is inside the square root, and that is this value. The derivative of a constant is always 0, so we have written 0 over here. Now we are going to solve this part of the equation. Now if we will differentiate this thing with respect to y, then this 8 will become 0, this will become 0, so we will be left with only minus of y to the power 4. So we will get, first we will write down this part, zy is nothing but the derivative of z with respect to y, and we will get 8 minus x square minus y to the power 4 into, so if we differentiate this we will get minus 4y cube equal to 0. Now since we have got a minus over here and we have a plus over here, so minus plus will become minus, and we will write x square zy minus 4y cube divided by 2 8 minus x cube minus y to the power 4 equal to 0. Okay, now we will cancel this and will become 2. Now we need to find tangent at the point 2 0 1. We have found this value with when we differentiated the equation of the surface with respect to x, and similarly we will do it with respect to y as well. So we will put these values in this equation. So we have value 2 for x and 0 for y and 1 for z. So here we will write 4zy minus, in place of y we will write 0, and this part will become 8 minus 0. So this entire part will become 0. So we will get z of y to be 0. So the derivative of z with respect to y we have got 0, and earlier we have got the value of zx. If you can remember, I have highlighted that part with red ink, and the value of zx was minus of 3 by 4. So now we have got the values of zx and zy, and now these values is going to be the final part of our solution. So this is the value of zy and zx which we have already got. Now we will put these values in the general form of tangent, which we have already written in the beginning of this video, and we have written that with equation 2. Now we will solve the final answer. So let us go here and write the general form of the equation which was there. So general form was z minus z naught equal to zx, x minus x naught plus z of y, y minus y naught. Okay, so this was our general form, and we have got the value of zx, we have got the value of zy. We will simply put the values over here, and we know the value of z0, x0 and y0. This is nothing but the point which was earlier given in the question, that is 2 0 1. So we will be putting these values in this general form, and we will be reaching to the last answer, the last part of this video. So let's put the values in this equation and try to find out what is the value of tangent. So we are putting the value z minus z naught was 1, so it will be 1 equal to zx. Our zx came to be minus 3 by 4, x minus x naught, our x naught is 2, so we will put the value 2, plus our zy came to be 0, zy was 0, so we will put the value 0, and y minus 0 because y naught was also 0. So you can see that this part is multiplied by 0, so this entire part will become 0. So what will be left with is only this part of the equation. So this part is z minus 1 equal to minus 3 by 4 x minus 2. Now this is very simple, anyone can solve it. We are cross multiplying it, so it will become 4 z minus 1 equal to minus 3x plus 6. Minus minus will become plus, and plus 6. So solving this equation, we will get to the point 4z minus 4 equal to minus 3x plus 6. So the final answer which we are getting is 3x plus 4z minus 10 equal to 0, or we can write 3x plus 4z equal to 10. Now let's go to the question and find that whether we have this this value or this option. So let us go to the question. Our question was this, that the equation of the tangent plane to the surface x square plus root under 8 minus x square minus y to the power 4 equal to 6 at the point this is, we have got 4 options. All the options were linear, so you can compare that this option is this one. So we have achieved the right answer, and the right answer is B. So the right answer to this question is option B. So this is our solution of this video, and if you have any doubt regarding understanding of this question or any question related to IIT JAM part 2019, then you can contact us anytime at this number. This is our number 9836793076 is our number, or you can visit our website, and our website is www.sauravsirclasses.com. This is our website. You can visit this website anytime, and we'll be coming with more videos of IIT JAM 2019 paper. And for this video, up to this, I hope you all understood this question. Thank you.